Hey, this is Wayne Mabe, and I'll be talking about my research on the biogeographic characterization of fishes in the intertidal SandFlat habitats in Pamlico River, North Carolina. To start with, Pamlico River has a diverse ecology of fishes, ranging from freshwater fish near Washington, North Carolina, to more estuarine-dependent fishes, as well as some marine species towards the mouth of Pamlico Sound. Commercial fishing is important to the river as well as the sound as a whole. Two of the more important fish species are blue crab and shrimp. These bring a lot of revenue to the area of eastern North Carolina for commercial fishing, as well as recreational fishing to the area. Few importances of estuaries are important habitats for juvenile fishes. There are several species that are marine-dependent species, but utilize estuarine systems as juvenile habitat. There are also several estuarine fishes that live their entire life cycle in the Pamlico River and Pamlico Sound as a whole, and these fish are generally the bay anchovies, Atlantic silverside, to name a couple. So the purpose of this particular study is, one, to characterize the fish community structure in Pamlico River. So I'm hoping to find changes in fish community structure and abundance among various geographical locations along the river. So to give a little bit of background about Pamlico River, it's located in eastern North Carolina and is an extension of the Tar River that originates in Roxborough just north of Durham. The Tar River then flows to the east and to Washington, North Carolina, where the name changes to Pamlico Sound or Pamlico River. The Pamlico River then runs 65 kilometers from Washington, North Carolina to the mouth of Pamlico Sound. Along this transect of river, salinities can change from near oligohaline, around 3 to 5 parts per thousand, up to 17 to 20 parts per thousand. The lower graph is showing an up-close map of Pamlico River in particular. The points located along the map are the various study sites. Pink circles were the ones selected for the study. The red points were the ones potentially used in the study, but were not selected by the random number generator. 18 sites in all were selected, and 6 were divided up into each one of the 3 sections, west, central, and east. So before sampling began, we took a survey of the river, looking for sandy beach habitats, shallow water, and areas with little debris. The purpose for these habitats was, one, we were surveying the fish communities along sandy habitats in the river. The shallow water was needed so that we could pull an 18-meter long bag seine, and then little debris was ideal so that we wouldn't have any hang-ups on our net as we pulled it back up onto shore. Every site that met these 3 criteria were then designated a 2-digit number. The coordinates were input into our GPS on the boat, and then these numbers were then entered into a random number generator back at the lab, and the first 18 sites selected by the random number generator were selected for our research. Of the 18 sites, they were then grouped into 3 groups of 6, and they were named west, central, and east based on location in the river. So after our preliminary survey of the river, we then went out the next week sampling the sandy beach areas using an 18-meter long bag seine. The seine was pulled back up onto shore, and then fish were identified using morphological features to species when possible. The first 50 fish of each species was measured for total length in millimeters and then released back into the river. Any unknown species were put on ice, taken back to ECU, where we then identified them using a Peterson field guide. data analysis was done using Primer version 6 software. And the three analyses that I'll talk about here in this PowerPoint is analysis of similarity. This was used to show similarity and differences among the three sections of the river. Multidimensional scaling shows the particular points that were surveyed during our 2-year study site and show how individual sites relate to one another in fish abundance and species assemblage. And similarity percentage was used to show similarity among the various sections of river, as well as what fish species were most important in structuring the community. So our results thus far are we collected 73,828 fish during our 2 years of collection. These fish represented 43 species. 5 species, the ones in bold in the table, accounted for nearly 97.5% of the total abundance. Looking at the table, the approximate size of adults, preferred environment, and economic importance were all collected from fishbase.org. The bottom 5 species on this table were the least common species. The approximate adult size is in total length in millimeters. Preferred environment, E is for estuarine, M is marine, and F is freshwater. And then the economic importance is to the right. So of the top 5 most abundant species, Atlantic menhaden and spot were the 2 most economically important. These graphs are showing the catch per unit effort per section, as well as species diversity. So the left graph is showing catch per unit effort. Samples were taken twice monthly for a total of 6 months, once per site. So to standardize this and get the CPUE, I took total number of fish caught per section and divided it by 12, which was a total number of seines that were used to collect the total number of fish. And as we can see, central portion of the river had the most abundant CPUE. The next graph is showing number of fish. So S is number of species on average caught per section of river. N is the average number of individuals caught per seine per section. And these bars represent the species and number in the bottom table. So as we can see, average number of species caught per seine in the eastern portion of the river was slightly greater than in the west or central portions of the river, whereas average number of individuals caught was highest in the central portion as opposed to the west and east. So looking at the Margalef and Shannon diversity indices, we can see that this is true, that species diversity is slightly higher in the eastern portion of the river as opposed to the west and central portions. So analysis of similarity, what this is showing, the dashed line to the right is our true R value at 0.079. The p-value is at 0.001. And the blue bars represent permutations run by the Primer ANOSIM program. So for every time the program ran an R value that supported the null hypothesis that there was no significant difference among section based on fish assemblage, there was a point placed on this graph. So our dashed line falls outside of the bar graph of permutations, therefore there is a significant difference in the fish assemblage based on section of river. Here's the non-metric multidimensional scaling of fish abundance. So just to walk through this real quickly, there is no scale on the X or Y axes. This is just relative. So points located closer together on the graph are more similar in fish abundance and fish species diversity than points located further apart. The data for this analysis was square root transformed to reduce the variability of the data based on outliers, and the 2D stress was at 0.15. This falls below the 0.2 cutoff, meaning anything from 0.2 and up based on stress makes the data unreliable. So because we fall underneath the 0.20 threshold, the data are reliable. The Semper function is represented in the table to the right. Average dissimilarity in fish assemblage based on sections of river, pairwise sections of river. West and east dissimilarity is around 57%. West and central and east and central are both approximately 55% dissimilar. And also based on analysis of similarity, the two most important species in structuring this dissimilarity were the bay anchovy and Atlantic silverside, accounting for nearly 55% of the dissimilarity. The remaining 45% was fairly evenly distributed among 10 other fish taxa. So in conclusion, we found that there were significant changes in the fish assemblage based on section of the river. The greatest differences, as were expected, were between the west and east sections. This is possibly due to salinity gradients, west being nearly oligohaline and the east being mesohaline. Bay anchovy and Atlantic silverside again accounted for roughly 56% of the dissimilarity, and if you add spot into that equation, that then bumped it up to 80 to 90% dissimilarity. So what I'm hoping to do over the next few months is analyze the water quality data that we're taking along with the fish data, use Canico to run canonical correspondence analysis to show how water quality affect the fish community structure and which parameters are the most important. And so I'm expecting water temperature, dissolved oxygen, and salinity to be three of the most important abiotic factors influencing the fish assemblage.